Hello, this is Anthony Manning. This is for the physics final, question 8. And this was about it's a two-part problem. It's about simple harmonic motion for the most part. It is the idea of first a pendulum and then a spring. For the pendulum part of this, it's focused on finding the small time oscillations, the actual period of oscillations. And for the spring, it's about this idea of like the equilibrium point and a spring being at rest, being attached to a mass, and this being compression and this being stretching. And at a specific time around the equilibrium for the spring, what is the K, the spring coefficient that it actually is? It's that's specifically in newtons per meter, because it's a per distance away from the equilibrium point. It would be how much force in newtons to do so. And that one was a little bit harder, even though it's the same formula, honestly. Both of these formulas we actually derived from in class from this, or a variant of this one, and we derived to both of these formulas. Pretty much, this was mostly just plugging in the numbers, and for the pendulum, I just got 21.24 seconds oscillation, given that there's no wind and nothing really acting on it, seeing as that was a part of the condition. It's just the length and gravity. So those are the only real forces mostly acting on it. And for the spring, I made a mistake. Ignore this part. I actually used the pendulum's time. That's why I got 9.8 newtons per meter, and that's just completely wrong because I'm using two different sets of information. When using 1.5, which was given from the question, it actually gives 1965 newtons per meter, and it's like a lot more based off of, for the spring coefficient, it's a lot more based off of just that one number changing. But that's what I got. Thank you, Professor.